Okay, so make sure you understand we have to make a choice. It's not both, it's one or the other. Okay, in some of these situations. We're going to come across situations where they make us select. Question 4. Question 4 doesn't use a half angle identity. It uses a double angle identity. So question 4, our example 4, doesn't actually go with that blue box. We'll have to use that blue box in a future question, which is really bad on my part that I put that blue box where I did. Oh well. All right, now. I know. I would say that sometimes there's a couple times where I'm like, why did they put that there when they should have put it over here? Sometimes that confuses me too. Okay. All right, so we need to make a replacement for the double angle formula right there, sine 2x. There's only one thing to replace sine 2x with, so it shouldn't be that hard. What is it? 2 sine x cosine x, right? That's straight off your formula sheet. There's only one choice. We're trying to solve this. We're trying to find every single x in the universe that would make this statement true. What should we do? Ooh. Put it all on one side. I love that. Nicely said. Look for a GCF. Do we have a GCF? Cosine x. So inside the parentheses, I would have 2 sine x minus 1. Thank you. Yes. 1. Now what? Set the factors equal to 0 and solve. Go. Set the factors. You've got one factor that's cosine x. You've got another factor that's 2 sine x minus 1. Set them both equal to 0 and start solving. The first one's going to be real easy, right? Cosine x equals 0. Because there's nothing to do there. The other one I have to do a touch work. Yes, good. Okay, so you got them both. Now go to your unit circle and start figuring out what angle measurements make that happen, what angle measurements make that happen. Yes, and yes. Nicely done. Okay, so we got the two things. We got that one and that one. So now we want to go to the unit circle and find what angles make those two statements true. So hopefully you have cosine x equals 0. And on the other one, sine x equals 1/2. Did we get to that part? Okay, any questions on that? So now it's time for you to draw a circle. Find the places that are true, the angle measurements that make either one of those statements true. There should be 4 answers to this question. Yes, those are the 4. Yep, y value 1/2, so draw a horizontal line right through it at 1/2 and see where it touches the edges of the circle and find those angles. This coordinate x out. This is an x value. You did the y value. It said sine x equals 0. Like 6 higher ups. The other one is not true. Cosine x equals 0. You did sine x. The y value is x. Yeah. Sometimes something equals 0. Have 2 things try together equals 0. And what do you know? You not have those things. Absolutely. doing the solving process. Just like if I said,
he didn't do anything.
But now we have to analyze this. Think about the circle and go, okay, that's a y value. Where do we have it? There's two angle measurements on the circle.
I didn't use that.
Yeah. So does it make sense why we have one half?
I made trouble, but I didn't know that he was able to hit 7 minutes.
Definitely.
That's a problem.
Now we're looking at these two things and saying, what angle measurements on the circle?
I heard it.
Yes. Yes.
It's December 93.
If the y value is a half, what two angle measurements did you come up with for y equals a half? Pi over 6 and 5 pi over 6. That's two of the answers. Cosine x equals 0. Is that an x value, a y value, or a slope? It's an x value. So if the x value is 0, what are the two answers? Ooh, there we go. We got them all. It does. Well, this is a weird one. Actually, I think it's better than I thought. Darn it. Cracking me up. Okay, we got a sine squared x. Now, I'm going to rewrite this side a little bit here. Whether I put the square after the sign or put it in parentheses with the square on the outside, it means the exact same thing. Is there anything that we know we could substitute for the part inside here? 1 minus nope, good try, good try. I suggest we go back to the blue box that has not been previously used. It's got to be this one, right? Now, since I'm squaring it, do you care if it's positive or negative? No, you don't. Right? Because that's going to disappear anyway. So make sure I copy this down right. Right? It was 1 minus cosine x over 2, right? I should have written that over here since I started that over here. Why am I doing that again? I don't know. My apologies to the chef. Okay, so what's happening to the square and the square root? Gone. So that leaves me with, maybe I should just, 2 and then parenthesis 1 minus cosine x all over 2. Any other magic happening? 2 from the top and the bottom cancel, right? So this question, man, this question simplified a lot to this. I do not like having sines and cosines all mixed up like that. One's a squared term, one's a linear term. So I think it's time to do a substitution. We're going to substitute something for that right there in that green box. And guess what? Your clue as to what you're going to substitute it is sitting right here. What are we going to substitute for that sine squared x? 1 minus cosine squared. That's right. 1 minus, let's go simple. Pythagorean identity. Taking us back to the basic Pythagorean identity. 1 minus cosine squared x equals 1 minus cosine x. And now what? Put it on the same side. I'm not a big fan of negative coefficients on a squared term, so I'm going to choose to move everything to the right side. Okay, so that gives me 0 over here. I got a cosine squared x and a minus cosine x. And then what? What? Okay, now wait a sec. What happened to the constants? They canceled, didn't they? That's right. Okay, we subtracted a 1 there, we subtracted a 1 there, and vanquished. Okay. We had to subtract the 1 to the other side, and in this case, they did cancel each other out, which actually makes my life pretty easy. Or I should say easier. Is there a GCF? Cosine x. All right. Factor out the cosine x. Leaving me what inside? Cosine x minus 1. Okay, set the factors equal to 0 and solve it. I think you're going to have 3 answers. Let me think, make sure I'm not off my rock. This is, yes, 3 answers. You got 2 of them, that's true. No, that would be cosine x equals negative. Cosine x equals negative 1 is there. I want positive. Yeah? Well, don't call it 2 pi because most of the time it'll say your answer has to be, like it'll actually say in the instructions, bracket 0, 2 pi, parentheses. So you can call it 0, but you can't call it 2 pi because most of the time I will have excluded that as a possible answer. So I just want 1 trip around the circle, so you would call it. Good answers. I like it. Yes. This is good. Good. Several of you writing cosine x equals 0 and cosine x minus 1 equals 0, which would create cosine x to be 1. And you went to your circle and you said, hey, I know that cosine x equals 0 happens there and there, which would be pi over 2 and 3 pi over 2. So those are 2 of the answers. Cosine x equals 1, that happens out here at the edge of the circle, which means we're dealing with what? 0. How come you can't call that 2 pi? Because most of the time, and I didn't do it here, but most of the time in the directions of the problem, it'll say something about 0 to 2 pi, and we'll have a nice big old parenthesis on the outside, which will take that option away from you. I know, technicality. It's time to work on some more questions together. We begin. 9? Whoa. Sensing some hatred. What did you decide, or what do you think we should substitute for sine 2x? 2 sine x cosine x. Yeah, folks, there's only one choice. Now, tangent. Should we leave it the way it is, or should we replace it with something? Maybe that has sines and cosines. Minus sine x over cosine x. What an excellent suggestion. We should get some common denominators or something here. What should we multiply this thing by? It's over 1 right now. Cosine x, what an excellent suggestion. Now, I hope this doesn't, rattle your cages, but watch that. Yeah, so do you understand that I multiplied the top and the bottom by cosine x? I just decided to shortcut it by putting a square on the cosine in the top. Does that make sense? I don't want it to seem magical. I multiplied the top and the bottom by cosine x. So I would end up having common denominators. Okay. Let me ask you a question. What does each term have in common that you could factor out? Okay, I want you to talk to your neighbors right now, and I want you to see or think about what you can pull out that both of them have in common. Yes. So why did you multiply the top and the bottom? Because I wanted them to have the same denominator. Okay. Because I can't factor anything out unless they have the same denominator. So how did you ever multiply it? Because I saw that this one had a cosine x in the bottom, so I knew I had to multiply that by cosine x, and if I multiply that by cosine x, I have to do the same thing to the top. So instead of writing 2 sine x cosine x cosine x, I could have written it like that. I just, in my mind, I said, well, that's cosine times cosine. Why don't I just write it as cosine? Does that make sense? Because I multiply the top and the bottom by the same thing. It's just I kind of shortcutted these two things together. If I say, I'm just making stuff.
I think it does because your finger just plays with my finger just It's really weird when this extra screen that everyone sees is shaking back and forth.
I did it once here and I did it once there, but since there was then I just combine those these two things together. So are we okay?
Yeah.
All right.
Because I've made so many
What you guys decide?
and I'm the one who actually gets it.
Yes! You pulled out a fraction, didn't you? You pulled out one thing from the top and one thing from the bottom. What'd you pull out?
Sine over cosine.
Sine x over cosine x. Which would leave me what? 2 cosine squared x minus 1. So what's sine x over cosine x? Tangent x. Now, don't go all crazy in factoring with me on this, okay? Because I think the wheels would fall off the cart if you start saying, oh, well, there's a difference of perfect squares, and let's see if I can factor that thing. Well, kind of, all right? Because you'd end up with radical 2 cosine x minus 1 and radical 2 cosine x plus 1, and I have a feeling that would just cause a whole lot of frustration. So why don't we just set the two factors equal to 0, and solve them? And once you solve them, obviously the first one's already solved. Second one, solve it. I think there will be 6 answers to this question. 6 answers. First thing I do is add 1, right? Then I would divide by 2. Then I would take the square root. Now the square root of 1/2. I don't think is what you're going to get there. Well, okay, what's the square root of 1? So the top would be a 1, and then the bottom would be radical 2. We could rationalize that, couldn't we? Because I bet you recognize the rationalized version a little bit faster. There you go.
You just said you were talking.
I think it's radical 2 over 2.
It's not radical 1/2.
That is the same thing as radical 2 over 2.
Oh, yeah.
There will be 6 answers. Yes.
I did it different though. I just pulled this line over and worked out like
Okay, if you pull the sign out at the beginning.
and I got that.
Yeah.
And I set those both equal to 0 and we got after the inside line across both the lines.
Well, my fear is right here that people wouldn't deal with that one very well. But you're right. It would work. It would work. That's another good way to handle it. All right, let me get myself some space. It'd be interesting if this thing had made like a squeaky noise when I did this. That sounded awful.
No, it was nice. I
No.
needed to crack my back.
Well, yeah, I'm not disputing that, but ooh, I just don't like it.
Sorry.
Mm-hmm.
One time I didn't crack my back for like 6 hours, and then I was in class.
6 hours.
Yeah. Like I don't know why. Like,
I don't crack my back
and
ever.
then so then I was in a really quiet classroom and I cracked my back, and someone was like, "Who just died?" 'Cause
Yeah.
There was like so many.
So several of you did this, right? And you guys were having a little discussion with me about what happens here, right? And so on the other side, we talked about doing this, right? And that's how we got the radical 2 over 2. What did I forget? Thank you very much. Plus and minus. Remember, I told you there would be 6 answers. Now, I knew that 4 of them were going to come from this. 2 from the positive radical 2 over 2, and 2 from the negative radical 2 over 2. And I was worried that you would forget the plus and minus, which would cause you to lose 2 of the answers. Okay, so now we start thinking circle. Cosine, is that x value, y value, or slope? X value, so we got radical 2 over 2 and negative radical 2 over 2. So what are the 4 answers you get out of that? Pi over 4, yep. 3 pi over 4. 5 pi over 4. 7 pi over 4. Knows too much? Whoa. Sounds like somebody's going to die here. Let's not do that. Okay. Tangent x equals 0. Is that an x value, a y value, or a slope? Slope of 0. What do you got? 0 and pi. Yes. So those are my 6 answers. All those pi over 4s, pi, and 0. 6 different answers. That is a really cool question. I like that one. Talk about stretching their brains. Sure. Question 11. Sine 2 theta plus cosine theta. Write the expression as one involving only sine theta and cosine theta. Okay, so we have to have single angles. No double angles. Which obviously means we need to do something with this. What are you going to put in its place? 2. All right. 2 sine theta, cosine theta, right? Do you have any more double angle? Are we done? Hey, next question. See, it's got single angle. That was a really easy one, right? Now, okay, don't look at this question and say, okay, I have to have everything in terms of either sine or cosine. That's not what it says. It said sine and cosine. You're allowed to have either one of them. Just no squareds. Well, I don't know. I can't say that. Maybe I better back up before I say squareds. But definitely no double angles. No double angles. Okay, no triple angles. Okay. Let's see if 13, I'm getting a bad feeling about 13. Okay, so what are we putting in the place of sine 2 theta? That should be pretty easy, right? 2 sine theta, cosine theta. But what about that cosine 3 theta? Drop what, Cheerios? I thought it was a microphone. Okay. We're going to split the 3 theta up into 2 theta plus 1 theta. So your attention right now needs to be focused on this part. The other part is pretty much done, right? Okay. What are we going to break that thing up into? Let's get rid of this so we have some more space. I think we need to go find that cosine sum formula that we learned about in section 5.3. Cosine 2 theta, cosine theta, right? Cosine, cosine. Now what? Minus, right? Because it switches signs. Sine, sine, right? By the way, I will not be throwing a cosine or a sine 3 theta at you on a test, because it gets ugly. It's a great homework question because it stretches your brains, but it's a little bit time consuming. Okay? All right. Do we have any awesome selections for what we want to replace these two things with? I mean, we can't forget that we have this thing at the beginning. That's still there, but we'll hold on to that to the very end because that's already finished. We'll include that in our final answer, but we got to figure out the rest of the stuff. Okay? Look at your formulas and let's make a choice. How many choices do you have for cosine 2 theta? 3. Do any of them, can we use any of them? Because remember, the goal is to get rid of every double angle in there. I can live with a square. I cannot live with a double angle. If you look at your 3 choices in section 5.3 for cosine 2 theta, is it 5.3? 5.4. If you look at your 3 choices, do all of them give you something that doesn't have a double angle in it? So how could you go wrong? You could really pick any of them. I'm not going to care. If this kid picks one and this kid picks a different one and she picks the third one, they're all right. Nice job. Makes my life a little bit difficult because now I've got to be watching what you're doing so I know whether you did it right. But I can't argue with all three of them because they accomplished what they were supposed to. So if we chose the cosine squared theta minus sine squared theta, then we have eliminated the double angles. And we only have one choice for that, right? Minus 2 sine theta cosine theta. Man, I'm running out of room. And a sine theta at the end. Okay. Can we help ourselves and try to simplify this a little bit? I am going to ask you to distribute this and then add any like terms together that you have. Okay? So, you've got this term up here at the top. You got to do that distributing. And you got this third term over here. And you got to think about what you have. Okay, so I'm going to freeze the screen, let you do this for obviously probably 3 minutes because I'm going to be running out of time shortly. Sine theta cosine theta. We have a cosine cubed theta. We have a minus sine squared theta cosine theta. And a minus 2 sine squared theta cosine Yeah, I really should have started in the upper left with this one and just allowed it given me the space.
I was sitting in my room at like 10 o'clock freaking out and I couldn't do it.
Okay, if you distributed, this is where you should be with the black that I've written down so far. I'm not saying it's done. I'm saying that I distributed and I wrote out my terms. Are there any like terms? Now, if you have a question, does everybody understand where the first term came from?
Yeah.
That was this box up here. Okay. Do you know where the cosine cubed came from?
Yeah.
Right, because you distributed that one there. Okay, when you distributed this one here, you got this sine minus sine squared cosine theta. Now, where'd that one come from? Right, this one down here. You got a sine theta and a sine theta, that makes a sine squared theta, right? Now, why isn't it finished? Why is this not finished? I mean, it's real close. Don't you have like terms right here? Do you notice I put one over the top of the other? I was hoping you'd be like, put them together. Right? Aren't they like terms?
Yeah.
So how many do you have? You got a -1 and a -2. That makes -3. You mean this one down here? Which one? Somebody asked?
Yeah.
2 sine squared theta. Where? The third part? -2 cosine, or this one down here? That's all being multiplied together. I mean, that's like saying if I had -2 times x times y times x, or sorry, that should be an x. Why wouldn't I, if they're all being multiplied together, can't I just square the x? Yes. And why did I use x for sine theta and y for cosine theta? Gee whiz, that's confusing. I don't know. Okay. I know. It would not be a test question, I will give you that. Okay. So we should get 2 sine theta. Sorry, I'm just trying to do a different color. You know, I know it doesn't show up very well on the white there, but plus cosine cubed theta minus 3 sine squared cosine theta. Well, it's simplified as far as you can get. It doesn't have any more double angles in it. Now, keep in mind that the goal is to have no more double angles. Do you know things that you could substitute for sine squared theta? Yeah, you could do like 1 minus cosine squared, right? Cosine cubed, I could break that up into cosine times cosine squared and then substitute 1 minus sine squared in for the cosine squared. When is it going to end?
When you want it. When there's no double.
That's why I'm saying to you right now, we got rid of the double angles. And we just combined, simplified a few terms together. Don't go ballistic with this. Alright? We just want to get rid of the double angles. We don't want it to go on forever.